So, as we talked in the last video, um, we see that our main file here seems to grow kind of fast, and it looks um, crowded. Um, we're not going to be writing um, all of our functions in the main file, right? And plus, well, we probably want to create an abstract data type or a wrapper class that is going to work um, on the node, so we don't have to do stuff like this. So let's take the first step and move all these DLL um, singly linked list related functions into their own file. So I'm going to create something like this where I'll put the functions into their own header file. The same way I include functions to use in this file, like printf and memory allocate malloc function. I'm going to do something similar where I'm going to put my code into a header file. So I'm going to move to the other screen here and create a header file. So I'll say vim slink.h. Okay, I'm sorry, slist.h. And then I'm going to put my files there. The first thing I'll do though, and I'll explain this in a little bit what it means, I'll have this preprocessor directive. I'll say if ndef, so if not defined, and I'll call this slist hpp. I'll say define slist hpp, and then I'll say end if. So we haven't talked about preprocessor directives, but essentially what I'm doing here is I'm creating this constant called slist hpp. So if this slist hpp constant, if it's not defined, go ahead and define it and then end the if here. The reason why I'm doing this is if this header file is included multiple times by mistake, it's not going to cause redefinition of the functions that are in here. Okay, and so I'll just say that for now, and then if opportunity arises, we can look at this a little later, these preprocessor directives. So at this point, I'm going to go ahead and pretty much copy my my code. So let me do this. I'm going to exit from here. So I'll say quit. I think I have to save it first. All right, and we'll do cat slist.c, and then I'm going to take the code that I had here, and I'm going to copy it, and I'm going to paste it over here, and the comments didn't quite work out. So I'm going to go ahead and clean up the code a little bit here before we proceed. Okay, so I've cleaned up the file here a little bit. This is my header file, and I just moved all of the functions that are related to the node. I moved them into their own .h file. And now I've included the h file, the header file, as hashtag include, and then I set slist. And this is the same way as I include other functions in C. The only difference you'll see that there are no caret signs. The caret signs means search in the library search path, so where the libraries or the header files are by default that are included with the compiler. When I put quotes here, this is a relative path. It means in the current directory currently. So I can specify any path I want here to search. If I don't specify any canonical or full path, this will just search the current folder. Okay, so let's go ahead and and run this and make sure that it works. So we'll say GCC, actually we're using Clang, and then we'll do slist.c. And let's go ahead and run it, and it seems to work fine again. All right. So I wanted to show you another tool. We've been using GCC or Clang. There's this tool called CPP, which is the preprocessor. You could also run it with GCC-E option, I believe, and then the file name. So this should, this does the same thing as the tool itself. So let me show you what this CPP is. CPP is the preprocessor in C. So let me run it. So before the file that I'm trying to compile, before it actually gets to the compiler, the file needs to get preprocessed. So this is what I was saying, these are preprocessor directives. This is the preprocessor can understand what these hashtag include means, or if you remember in the header file, I had if not define, and then end if, and they were all with hashtags. Okay, so that's part of the preprocessor. That's how you can do, if you're familiar with C, that's how you can do macros or generics in C, or substitute different types. It's done through one way to do it is through the preprocessor. So let's see what actually happened here. This is the file that I'm going to feed to the compiler, and you see the file is pretty big, and you say, hey, what is going on? I thought this was our file here. Why is this file so big, and what are all these things here that you're scrolling through? Well, I'm not going to keep scrolling because it's a pretty gigantic file, pretty big file. I'm going to focus on the last part here. So there's my main function right here. Okay, there's the main. But above main, so this code here, if you notice, matches the code that I've highlighted here. All right. And then if you look above it, there's the remove node, there's the free list, there's my print list function, there's my node struct, and then above it, then I start getting this, at this point, maybe weird looking stuff. So what happens is the preprocessor goes to these files, and whenever I say hashtag include, it's going to copy the contents of this file, and it's going to put it right here where the hashtag include is. Okay, so in our case, this whole file gets copied. In place of this file gets copied, and this file gets copied. That's why I get this really big file, and this is the file that actually gets compiled, right? Because we haven't talked about dynamic or static linking yet, and if we have time, maybe we will. But this is something you would we probably won't talk in the introduction here. But this is something you would learn like in a systems course, or if you took a C++ course, you would learn this. Okay, so let me, before I move on, I want to show you what the preprocessor can do. So I can use, if I go ahead and let's clear the screen, and we'll open my slist header file. Right, so these are preprocessor directives here. Okay, so I can use these here. I can use these to define compilation specific instructions where the code doesn't have to be recompiled in order to take different paths. So what do I mean by that? Let me give you an example. So let's say I have this code here, and I want to generate executables for both a Windows and a Mac machine or a Unix-based machine. Now, if I'm dealing with system-related calls, maybe I'm doing file input-output, maybe I'm dealing with sockets or with the network or with threading, and the low-level system functions, they have different names, or maybe they're written differently on a Mac operating system, whereas the system calls on a Windows are written differently. So now, how do I write only one file? How do I not have a file for a Windows machine and then a file for a Mac machine? This doesn't make any sense. We're not going to be maintaining copies of the same file. So one way to do this is to say, all right, well, we can say int, and we'll say is Mac, and that will be equal to 0, right? And then here I will say, hey, if it's a Mac, if is Mac, if that is a 1, right? Then I'll say, okay, we're gonna go ahead and maybe just try to pretend we'll say we'll do a Mac specific system call. So I'll just say here, I'll just do a printf for now because I don't want to, we're not going to do system calls now. This is a printf, this is a Mac related system call. All right. And then I'll say else, we'll say printf, this is a Windows related system call. All right, so now depending if I'm on a Mac, depending on if I'm on a Mac or a Windows machine, I can change this flag here, right? And then generate, either generate this message or generate this message here. So if I go ahead, let's say, and I leave it as a 0, so technically this will say this is a Windows related system call. Let me get out of here. So we'll say gcc slist.c. Oh, right, we need to do it with clang. So we'll say clang slist.c, and let's go ahead and run it. And oh, it didn't say. Interesting. Maybe I didn't save this file? Let me try that again. Try this again. Oops. Okay. Let me clear the screen and redo this. Okay. This is a Windows related system call, and then if I change this to a 1, right, and I save it, and I come here and do the same thing, have to recompile, run it. This is a Mac related systems call. Okay, the only issue with this is that I have to recompile everything. I have to recompile the I have to, actually compile to see this change. Okay, let me show you what I mean by this. I'm going to uncomment. I'm going to uncomment these header files here just for the time being. I'm just going to include a stdio for now. All right, and then we'll just get rid of, I'll just comment the list related code. Okay. All right, so now when I come here and let's say I try to pre-process this file here, I'll say cpp slist.c. This is the code that will get recompiled. The code is still here. So when I say is Mac, this needs to get compiled, and then the issue though that I'm seeing here is that You see how it's funny that the comments are not there, by the way, in the preprocess file, right? Because nobody's going to read the preprocess file. I still have this if-else statement here. So I'll have to compile. I'll have to go through all of this. Now you might say this is not an issue, but what if I have a lot of these statements, right? The code might get pretty big, and we'll have to compile unnecessary code that we don't really need. Like, I don't need to compile this if statement here, if else. If it's a Mac, I should just run this. And if it's a Windows, I should just run this. I shouldn't be having an if else statement here in the preprocess code. So this is where we can use the preprocessor to our advantage. So I can come here, and instead of saying this is an integer, so this is a variable, I'm going to kind of play with the with my preprocessor, and I'm going to say define, and I'm going to use let's say I'll call this Mac build, and then instead of using an if statement from the language that the language gives me, I'm going to use the if statement that the preprocessor gives me. All right, so now I'll say here, hey, if defined, and then I'll say Mac build. Actually, there's an easier way to do this, so we'll just say if Mac build, right? Then we're going to do this here, and then I'll say, as opposed to using a regular else statement from the language, right? I'm going to use a a preprocessor else statement. I'll say else, and then at the end I will say here and if. So now this is pretty cool, because look what will happen when I'm going to use the preprocessor directives here. Okay, so clear the screen, and I will say cpp slist.c. Oh, maybe I didn't save the file here. Let's save the file. Let's try this again. Okay, so we'll say cpp. All right. It says, oh, did I have an error? Did I? Oh, my bad. You can't have a equal sign in a these are called macros, but I haven't talked about macros explicitly. But I'm defining Mac build as one. All right, so let's try that again. There's no equal sign in the preprocessor symbol here definition. So we'll do this again. Cpp slist.c. Oh, and no semicolon, right? All right, let's try that again. Okay, good. So now if let me bring this up a little bit. Now if you look at my main, this is the code that will only get compiled. It just says, just a printf, this is a Mac related system call. So the preprocessor actually went and preprocessed our code before it was actually built. So it figured out that Mac build is defined as here, right? We define it, a 1 means it's defined. And we went ahead and we said, hey, this is 1, so we're going to do this statement. And then the preprocessor just got rid of our our else and if here, because that's only what we want to print. So this kind of saves us writing if-else statements that are going to stay in our code and then need to be compiled. And not only that, but our file is going to be smaller, right? If this is only the code that will run, right, then why have another 4 or 5 lines in there that they're not relevant to this compilation here. And you can do different things with the macros. So let's just go ahead and test this if this is a 0 and see what happens, right? So I'll say, right, we'll come here, we'll clear the screen, and now you see now it says this is a Windows related system call. Before it said it was a Mac related system call. Right, so pretty nice. What you'll notice is that the blank lines here that used to be here. That's what I'm guessing where the blank lines went. Why are they here? But anyway, the other thing I can do is I can define not just ints here. I can say define. I'll say message, and I'll say here this is a Mac. And then I can, I can define these preprocessor symbols. So now instead of saying printf here, I can just say print message. And the nice thing about this is, again, I can change this without having to recompile my entire code. Right. So if I change the message here, the whole code doesn't need to get recompiled because it'll just get pre-processed. So this is, C is used for, embedded systems and low level. Usually it was. I mean, it's used for many things, but we use C so we can get maybe some speed advantage. Excuse me. So let's go ahead and save this. Oops. And try and see what happens here. So I'm going to define this as a Mac build so I can see the message be printed actually. So we'll say 1 here. All right, and then I'll come here again. Clear cpp slist.c. Now it says printf this is a Mac. So this is the code that will get compiled. But in order for me to change the string, I didn't have to, I didn't do something along the lines of, I didn't do char message. I didn't do this, where this would have, this would have to be compiled to figure out what the message is, right? So this will not have to be interpreted at runtime. So that's the difference between, I have to compile this code to, if I put this message here, this will have to be interpreted, either when later in the stages. But now when I compile the code, but this way, this here is the code that will get built, so nothing gets, there's not a variable there. All right. So I hope this this kind of made sense. I can do other cool things with macros.